Hello viewers, Rowa taking you through the story for A-level principal mathematics. And this video, we are going to go through the expected response for Senior 5 Math Paper 1 end of Term 3 for the year 2025 for Gayaza High School. So this video is suitable for students in Senior 5 offering principal mathematics as part of their combination. So like you're well aware, your curriculum is mainly scenario-based, though some schools are still setting old curriculum way, but they have to adjust by all means. So we shall go through the items which were set by Gayaza High School as end of term 3. So, but that doesn't mean that setting old curriculum way is misleading. It is a way of having a wider scope of settings. So what some schools do, they prefer setting two sections, section A, which is old curriculum, and section B, which is new curriculum. But the new curriculum is here to stay, so the questions will always be scenario based. So item 1 says, the science club at Sunrise High School is preparing for an upcoming STEM exhibition and regional science workshop. To plan effectively, the club needs to rent exhibition booths, secure sponsorship installments, and select a representative for the workshop. Use the information below to answer the tasks that follow. So bullet 1, the club intends to rent 3 adjacent exhibition booths along the main corridor. The rental fees for these 3 booths form an arithmetic. This is the keyword. Form an arithmetic progression. The total cost of the 3 booths is $360 US, and the product of their costs is $1,428,000 US. Bullet 2, to support the exhibition, a local company agrees to pay a series of decreasing sponsorship installments, each being a fixed fraction of the previous one, hence forming a geometric progression. The sum of the first 2 installments is $900 US, and if the company continued paying indefinitely, that is to infinity, the total sponsorship value would be $2,500 US. The science club plans to start the exhibition project as soon as the total amount of the money received exceeds $2,000 US. From the science, another bullet, from the science club's membership, 6 boys and 4 girls, a team of 5 members must be chosen to represent the school at the regional science workshop. The team must include at least 3 boys. Okay. Task: determine the rental fees for the 3 booths. And part B, determine the smallest number of installments that should be made for the science club to start the exhibition project. And part C, determine the possible number of ways of selecting the team to represent the school at the regional workshop. Okay, so we shall begin with task A. Task A, if you look at this previous slide, it comes from this bullet, first bullet. So in this bullet, the keyword is arithmetic progression. Okay, and they are consecutive. So if the first term is A, another one will be A plus D, another one will be A plus 2D. That is one way. Another one can say, let my first term be, okay, let my middle term be A. So the third term will be A plus D, and the first term will be A minus D. Both are okay. Whatever I choose is okay. So when I add these ones, I should get a total of, let me see, when I add, I should get a total of 360. And when I multiply, I should get a total of 1,428,000 US dollars. And those are two equations, two unknowns, meaning you can easily solve simultaneously. So let's see what to do. So the sum will be, first term is this, second term is this, and third term will be that. So the sum should be 360. When I simplify, I collect like terms to come up with this, reduce the equation to come up with a plus d equal to 120. Then make a the subject and come up with a equal to 120 minus d. For the product, when I multiply, I should get this. So, but the good thing, I already know the value of a. So what I'm going to do, I'm going to substitute for a, put here a, put here a, put here a. You realize that in this case, this and this cancels, so I remain with 120, which is here. This one is here. Then for this one, this and this becomes 120 plus d. So now I have one unknown. I need to expand and make d the subject. So here what I did, it was difference of two squares. So this and this is a difference of two squares because there's a sum, there's a product, so there's a sum and difference. So 120 squared is this, and this squared is this. This one goes this side by dividing to come up with 11,900. Collect like terms, take this one this side and this on this side, you come up with d squared equal to 2,500. Therefore, the value of d will be positive 50. So the rent of fee for the first, both will be first term, this one, substitute for d to get 70 US dollars. T2 will be this one, so substitute for a and d to come up with 120. The third fee will be this, substitute for a and d, you'll come up with 170. Then we can conclude. Rental fees for the first, second, and third booths are $70, $120, and $170 respectively. So basically that was part A. Now let's see part B. Part B says determine the smallest number of installments that should be made for the science exhibition to start, for the science club to start the exhibition. Remember here they told us, but this was the bullet begins from here. So this bullet is for part B. From here, what we want from there is the word geometric progression. Once we see that word, we can now come this side and say the sum of the first two. So if the first term is A, the second term will be AR. When you add the two, you should get 900. That is equation 1. Then they said, and if it is continued indefinitely, indefinite means sum to infinity, so sum to infinity, it should be 2,500. Okay, then they said they will start when the amount received exceeds. So when Sn is greater than 2,000, that's when they can start. So here these are two unknowns, A and R. So the good thing, we have two equations. This is equation 1 and this is equation 2. So you can use those two equations to get the value of A and R, after which you shall use this condition to get the value of N. So let's do that. So sum of the first two terms is that, like I've told you, make A the subject to come up with equation 1. Sum to infinity is given by this. Make A the subject to come up with equation 2. So there's this A and there's also this A, meaning I can equate the two equations. So now I have one unknown. I can now solve it, cross multiply. So this times this is difference of two squares. That's what you see here. Then here, these two zeros can cancel. That's why you see here there is 9 and here there is 25. Then making r squared the subject, r will be equal to 0.8. We take the positive value. Then from equation 2, which is this, I can easily get the value of a. So now I know the value of a, I know the value of r, meaning I can now use the condition. They start when the sum exceeds 2000. So Sn exceeds 2000. But I don't know the value of n, and that's what they want, the number of installments. So substitute for Sn, which is this. We already know that r is smaller than 1. That's why I'm using 1 minus r. Okay, substitute for a and for r here and here. So now that means that we only have one unknown, which is n. So let's try to solve for n. So here you realize that this one gives you 0.2. Then 500 divided by 0.2 gives, let me see calculator. 500 divided by 0.2, it gives you 2,500. Then that 2,500 goes this side. So I'm going to divide 2,000 divided by 500 to give me 0.8. So that is why you are seeing this side. There is 0.8 here. It came from 2,000 divided by 2,500. Collect like terms, take this side and this side, you come up with this expression. Okay, then introduce log on both sides. Then when you divide, the sign changes. I think you know that this one, log of a number which is less than 1, is negative. So if you press the calculator, log of 0.8, let me see, log of 0.8, it is negative 0.0969, like that. So when you divide the sign has to change. That is why we are saying here greater than. It was less than, isn't it? But now it is greater than because of this negative of dividing by a negative value. So in the end, we'll come up with n is greater than 7.2126. But the number of installments are whole numbers, so the smallest should be 8. Because here it says greater than, the integer which is greater than, the smallest integer greater than, that should be 8. So now we shall go to part C. Part C, they say that determine the possible number of ways of selecting the team to represent the school at the regional science workshop. So that comes from this bullet. They said the club membership contains 8 boys and 5 girls, and they want a team of 5 members to represent. But in that team, it must have at least 3 boys. So that means that I have a number of options. I have 6 boys, I have 8 boys and 5 girls. So I can either choose to select, at least 3 means 3 or more. So I can select 3 boys, or 4 boys, or 5 boys, or 6 boys. Because I want a total of 6, if I select 3 boys, I'll need 3 girls. If I choose 4 boys, I'll need 2 girls. If I choose 5 boys, I'll need 1 girl. If I choose 6 boys, I'll need no girl. So all those options should be catered for. And 2, there is permutation and combination. Permutation is used when your mind the arrangement. Mind the arrangement. In this case, we don't mind the arrangement. We only want selecting. So we shall use combination. Therefore, I'll come and write all the options. I can choose 3 boys, 3 girls, 4 boys, 2 girls, 5 boys, 1 girl, 6 boys, no girl. Then I use a calculator. This one gives me this bracket gives me this bracket gives me this, and this gives me that. Adding up gives you those number of ways, and that's what they wanted in that item. Item 2 says, in a week, a surveyor is measuring the heights of 2 nearby hills, Hill A and Hill B, using angles of elevation from a certain observation point. The angle of elevation to the top of Hill A is alpha, and the angle of elevation of Hill B is beta. It is known that sine alpha is 4/5, and cos beta is 5/13. The surveyor observes the angle. Accurate angle can be obtained by solving the equation, this equation. She notices certain patterns in cosine and sine functions and wants to verify her observations mathematically. Okay. Part A. As a mathematics student, help the surveyor to determine the following. 1. The exact value of sine alpha plus beta without using tables or calculator. The exact value of tan alpha plus beta without using tables or calculator. Then solve the equation in that interval, and then prove that this is equal to that. So we shall begin with what is given. We are given that sine alpha is this and cos beta is that. So I can now draw triangles. They are all positive, meaning they're in the first quadrant. So sine is opposite over hypotenuse. So I can put here 4 and 5. Then here I can use Pythagoras theory to get the value of adjacent. For beta is adjacent over hypotenuse. So I can use Pythagoras theory to get the value of opposite. When that is done, it means I can now get the value of cos alpha and sine beta. Then I'll start answering the questions. Sine beta plus alpha, I use compound angle formula. This is the same as sine alpha cos beta plus cos alpha sine beta. Then you substitute, sine alpha is here, cos beta is here, cos alpha and sine beta. So I'll come up with 56 over 65. Then for part B, they want cos alpha plus, they want tan, but you first get cos alpha plus beta, which gives you cos alpha cos beta minus sine alpha sine beta. So you substitute, and then you can divide to get the value of tan. And that's what they wanted. Then for part C, they want you to solve this equation. Okay, the first thing is to change this so that they only have one ratio. So shall come. So part C, we are given that. So the first thing to do is to use Pythagorean identity to come up with this. Sine squared 3x is the same as 1 minus cos squared 3x. Then open bracket and rearrange to get a quadratic. which can be solved using the quadratic formula to get the two values of cos 3x. Then from there you can get the values of 3x. For when cos 3x is equal to negative a third, this is the angle basing on the range, because the range was from 0 to 90, meaning 3x should be 0 to 70. Then for this one, it is undefined because it cannot exceed negative 1. So that means that the angle they want is this. That was part C. Then part D was about a proof, proving that this is equal to tan, let me first see, that was equal to tan, I think. Yeah, is equal to tan 4 theta. Okay. So left hand side is that. We shall begin by rearranging. Why do you rearrange? Because, for example, if you use these two angles, you'll come up when you use that and use this, it will still be okay. But let me see what you get here. This plus this over 2 is 12, divided by 2 is 6, and when you subtract, you get theta. What about down? Down is also still the same, so it is okay. It will still give you the same answer. But okay, let's rearrange. So what I did, I brought this close to this and this close to this. I rearrange, but even if you don't rearrange, it still gives the answer. What you want is you to pair correctly. For example, if I choose to pair 7 theta and 5 theta up, even down, I should pair 7 theta and 5 theta. If I choose 7 theta and 5 theta and then I pair 7 with 3, then their problems will have begun, though you are still arrive at the same answer. So when I pair these two, I'll come up with 2 sine theta cos 3 theta. And pairing these two, I'll come up with 2 sine 4 theta cos theta. Do the same down. 2 cos 4 theta cos 3 theta. 2 cos 4 theta cos theta. Like that. 2 is common, meaning it can cancel. Okay? Then when you look up, sine theta is common. When you look down, cos 4 theta is common. So I can factorize them out. When you factorize out, you realize that this 2 goes away. This also goes away with this. So I remain with the sine over cos, which gives me tan. And that's what they wanted. So basically, proofs of trigonometry, you need to be concerned with the identities. That was item 2. Item 3 says a student was to estimate an approximate value of a number. However, the teacher told the student to use his knowledge to decompose a function into partial fractions. The function to decompose was this. Okay, task 1. As a student, express that function into partial fractions and hence find the binomial expansion as far as the term in x squared. The word hence, be mindful of it. Then for part B, prove by mathematical induction that this summation is equal to this. Okay, so let's begin with task A. So this one will be equivalent to this. Remember, this one has repeated roots, so the same as this plus that. Be mindful of the equivalent sign. Then you can equate the numerator after getting the common LCM. You can equate the numerator. So here the numerator will be this. Then after getting the common LCM, it will be this times the LCM, which is this the LCM, which is common. So this times this, you remain with, there is x plus 2 squared. Then this times the whole of this, you remain with 3 minus x, then 2 plus x. Then this with this, you remain with 1 minus 3x. So next we shall now put, because there is an equivalence sign, we can put different values. So putting x equal to -2, you substitute. When there's -2 here, it is 3 times 4 to give you 12 plus 16, which is here. Then here, this will cancel, will become 0. This will become 0. So you only have this, which is 1 minus 3 times -2, which gives you 1 plus 6, giving you 7, which is here. So in the end, I'll come up with the value of c as 4. Then putting x equal to a third. X equal to a third means, okay, this side it will be 3 times 1 over 9 plus 16. But this side, this will become 0. This also becomes 0. So I remain with only this. So that is a third plus 16, and this side there will be 2 plus a third, everything squared. Simplify to get the value of a as 3. Then putting x equal to 0, this side, this is 0, should also remain with 16. And this side here, there will be 2. Here there will be 1. Here there will be 2. Here there will be 1. But the good thing, I know the values of a and c. So I can substitute for a and c and be able to get the value of b. Then from there, I can substitute for a, b, and c to get the required partial fractions. After that, they told us to use binomial expansion to expand up the term in x squared. So these ones are the ones I will expand. We could not expand when they are still in the denominator. That's why we have to pull them up. So for the first term, the power is -1, so it will be 1. We're using the expansion in the binomial theorem, and it's also there in the logbook. So how does it go? If it is a, if it is 1 plus x to power n, the first term is always 1. Then the second term will be the power, then x over 1 factorial. Then plus the power, then power minus 1, then x squared over 2 factorial. So in this case, the power is -1, which is here. Then here, what will be our x is now -3x, which is there. Next, the power, which is -1, then reduce it by 1 to give it -2. Then that term squared is here over 2 factorial. Then you can use the calculator to get a simplified version of it. Do the same for this second term. So here what I wanted is to first make the quotient of one of the term equal to +1. That is why I factorized out 2 here to be able to get this 1 inside. Then I can use the same expression to get the expansion. I'm stopping at x squared because that's what they told us in the question. Then I can now add the 2 to come up with the final answer. That was part A. Part B was about a proof by induction. They are given us that this summation is equal to this. So proof by induction has steps. The first one is when n is 1, then when n is 2, then the third step is an assumption when n is k, and the fourth one is when n is k plus 1. All should be consistent. Consistent, I mean left hand side is equal to right hand side. So for left hand side, n means the number of terms. So here the first term is this, which is half. But for the right hand side, n means substitution. So put here 1, you come up with this, which gives you still. Because the left hand side is equal to right hand side, we can say that it's true for n is equal to 1. Also test for n is equal to 2. Left hand side means 2 terms. So you come up with 3 over 4. Right hand side means you substitute for n here to get this. They're still equal, meaning it is true for n equal to 2. What about n equal to k? N equal to k is an assumption. When it's an assumption, it means you just substitute where there is n, you put there k. Where there is n, you put there k. So for n equal to k plus 1, it means here you add the next term here. And here you increase where there is n, you put there k plus 1. That's why you're seeing here k plus 1 for the right hand side. Left hand side, you add another term. So from here, we added another term to make it k plus 1 terms. But the whole of this, we made an assumption that it is equal to this one. Second substitute. When I substitute in the proof, I already have one here. So what I'm going to do, I'm not going to tamper with this one. That is why I put this in bracket. Because I've already got one. Now those in brackets are the ones which I need to deal with so that left hand side is equal to right hand side. So 2 to the power k plus 1 is the same as 2 to the power k times 2 to the power 1. This 2 to the power k and 2 to the power k are the same, so I can factorize them out. I remain with 1 here and a half here. 1 minus a half is a half. Then this and this gives you 2 to the power k minus 1. And that would be the answer. So now the left hand side is equal to right hand side for n equal to k plus 1, meaning I can now conclude. And they will have proved by induction. Then item 4 says, fine sand is dropping on a horizontal floor at a constant rate of 4 meters cubed per second and forms a pile whose volume V and height H are connected by the expression this. A man wants to collect the sand in an open box and has a rectangular sheet of paper of length 45 meters and width 24 meters. He should cut squares of length x meters from each corner and bends the edges upward to form the box. It was observed that a 5% error was made in measuring the side of the tube of length x meters. Task: find the rate at which the height of the sand is compiling when its height is this. Then find the expression of the volume of the box and hence find the dimensions of the box, given that the box must have a maximum capacity, and C, find the percentage error in measuring the volume of a tube. So one, the good thing, we are given the expression of V, and this expression, there's only one unknown, one variable, so I can easily differentiate. If there were two variables, I could look for a way of eliminating, expressing one in terms of the other before I differentiate. So this is called a function in a function. To differentiate, this is 0, that's why I'm not seeing it anywhere. Then here, bring down the power, reduce the power by 1, then differentiate the inner bracket. They will have differentiated the function in a function. Then I can substitute with the value of h which are given. We are told that height is 2 meters. Therefore, the h dt by chain rule is equal to the h dv times dv dt, which gives you 5/2. Then for part B, let me see part B. Find the expression for the volume of the box and let's find the maximum dimensions. Volume of the box, we shall now deal with this one. There's an open box, it has a rectangular sheet of paper. This is 45 and this is 24. So they cut squares on either side of x, meaning that now here, when they cut, this becomes 24 minus 2x, and this becomes, okay, let me put it here, it becomes 45 minus 2x. So this is the length, this is the width, and the height is x after making the box. So with that seen, we can now come and say that for the cuboid, the length is that, width is that, and height is that. Therefore, volume is got by LWH. Expand, I brought this inside here to come up with this. Then expand again to come up with that. This can be collected, so we collect like terms to come up with that. Then I can differentiate. Because they said maximum, I can equate to 0. So that means I can get a quadratic and solve it using quadratic formula to get the two values of x. But x cannot be 18. Why? Because when x is 18, remember we had 24 minus 2x. So when x is 18 means that it will be 24 minus 36, which is a negative. So x cannot be 18, therefore x is 5. And after concluding this, then you can now get the new length, the length they want, the width, and the height. And those will be the dimensions. Part C, they want the percentage error in a cube. So 1% error in measuring the side is 5%, so error will be 5% times the total length to give you this. Volume of a cube is x cubed, differentiate to get 2x squared. Then small change in increment in volume will be dv dt times small change in x, this times this to give you this. Therefore, percentage change in volume or percentage error in volume will be delta V, which is here, over the V times 100 to give you the answer. And that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded that this video will be on Math 2 still end of term 3 for KHS. So if you are not subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know any student who's not yet on this platform, please share the link of this video on them by social media platforms like Facebook,